Hi, so this is the first in a series of videos for National 5 applications. We'll do an area in this video, and just to give you an idea of what else is coming up, if you go onto the National 5 Maths website, yeah, just scroll down, you will get to all the different worksheets, and I'm going to start here and work my way down. There's also past papers. I was tempted to work through them, but I thought this way it really is just topic by topic, and it helps, I think, identify the patterns and the kind of questions that you get. This is good to kind of make you think, well, what is the question asking? But this is if you want to hone in on each of the specific topics uh, and see what you like. So yeah, 26 odd topics. We're trying to go through them. So let's make a little start then with area. So as always in these videos, I suggest you have a look at the question, have a little read, and maybe pause the video, have a go yourself, and then check to see what the solution is if you want. So the middle of the video might be quite boring for you. Just get the question, see the question, see if you can do it, check the answer, see what you went wrong. Don't feel you've got to listen to me yammer on for ages. Okay, so we've got a flag in this shape. Calculate the area of the flag. Flag enthusiasts out there will know there is only one non-quadrilateral flag, and that is Nepal. Anyone's a big fan of vexillology? There we go. So for this flag, what we've got here is a rectangle and a triangle. First thing, break your shape up. Break your shape up. I would then actually start with a little bit of English on the side. So I've got a rectangle. Oh, I can spell that. Got a triangle. Just to get it straight in your head what you're doing. This is where, if it's half a rectangle or half a triangle, whatever, this is where the English can help, just to get it straight in your head what you're doing. Now, we should know that a rectangle is base times height. I'm just going to write BH. And a triangle is half times base times height. And I'm using the base and the height terminology for capital H, actually, just to keep it the same for both shapes. And it's important when you're doing area that you remember your base and your height are at 90 degrees to each other. So if you've got a kind of funny looking triangle, let's say it's something like this, your base would be this dimension here, and your height would not be, the height wouldn't be these lengths. They're not right angles, are they? The height would be at right angles to base. Okay, so that would be the height that goes up to the top of the shape, doesn't it? So just watch out when you're doing these. It has to be perpendicular to each other. So the rectangle is pretty straightforward. Just 4 times 10. I'll put a little times actually in it up. And that's 40. I'll just send squared, area, square area. And the triangle, we're thinking, okay, a half. My base is the same. Base is the same as this shape, so I've got 10. And the big mistake here is to say 13 is your area. That's not correct, is it? The height, as we just discussed, has to be 90 degrees. So that is the height. We're not given that height though. And this is a favourite part of this topic where they make you use, what do they make you use? Pythagoras to calculate that. So just on the side here, I'm going to do a bit of Pythagoras. So I've got my right angle triangle. The base of this triangle is going to be half of the 10, so that'll be 5. The height we're trying to find, I'll call it x, and that's 13. So if you've done this enough, this is done on calculator paper, you should be knowing that's 12, because you get a 3, 4, 5 triangle, that's pretty common, and also 5, 12, oops, I've written that wrong, 5, 12, 13, also very common. 5, 12, 13, very common. What's the other one? Is it 6, 8, 6, 8, 10? Yeah, 6, 8, 10 comes up a bit as well. So those are your wee Pythagorean triples, they pop up quite a lot. So watch out for them anyway, just so you know. But let's work it out, see if we didn't remember that. I have got the hypotenuse given to me. So if I know the hypotenuse, it's opposite the biggest angle, which is always the right angle for these triangles. So it's going to be 13 squared, take away, we do a take away when I know the hypotenuse is x squared. It's going to be 169, take away 25 is x squared. So that's 144. So then x is the square root of that, is 12. So fantastic, I now know that that is 12. So I can say it's half of 10 times 12. At this point, you can do a 10 times 12 and then half it. Or you can make life a bit easier if you wanted. You could say, I'm going to do a half of, and do whatever number you like. I'm going to do a half of 12. Do 6, and 6 times 10 is 60 centimetres squared, for a final answer of 100 centimetres squared. I'll just check the answer as well. Boom. So that's actually quite a lot in that for the topic. That covers quite a lot of your bases. You've got the fact you need to know it's base times height. You've got two different shapes. The triangle's a half base times height, and a little bit of Pythagoras as well. Again, I'll let you have a read of that. Feel free to pause. So in this question, we're looking at fencing. So we seem to have some fencing. This is trying to make it a wee bit trickier for you. I'm going to use my highlighter for this. So some of these questions can be quite wordy. It's really good to practice the questions, right? Because they do try and make them in context, which can add, the wording can add to the complexity. The fencing is this bit here. So we've got fence here and here. And then we've got our buildings. So I'll just put the buildings in. A building is like a square. So there's a house over here. Yep, absolutely. We've got a shed. Okay. So you can kind of imagine that looking and plan. You've got your house at the back, you've got your garden, papers away at the edge, you've got a wee shed. Yeah, I can get my head around that. We've got a brick wall. Okay. So the fencing, right angle to the house. Now a lot of these words are really obsolete. The fencing's at right angle. All that really means that's a right angle. Okay. The wall is at right angles. Again, because they've drawn it out, they need that. And fencing panels are on 2 metre sections, and that's how much they cost. The minimum cost of buying the fencing. Okay. So that will obviously come in handy. But the first part of this question is saying, what's the how doing? Sorry, because that's what we did for the fence. The question is really saying, how long is your fence? Working out. So let's do that. So first of all, my fence is going to be two sections. I've got the tapered section and I've got the flat section. Please use a ruler. I've still not quite sussed out all the features of this anyway. So I know I've got 6 meters. That's fine. I'll call this the diagonal, the horizontal. So how do we work out that distance of diagonal? We can't just work that out. No, it's not on the diagram, is it? So we need to make, if you see a diagonal, you're thinking to yourself, it's going to be Pythagoras. Notice again, that's the second question. Pythagoras is involved. They love put Pythagoras in here. So what is the height here of our inclined section? We're going from here to, well, this is 2, and the full thing is 4. So the difference between 2 and 4 is 2. So that has to be 2 meters, doesn't it? If I'm going up 2, I would need to go up another 2 in order to make 4. And then it's the same with this one. The whole thing is 10. This width is 6. 6 plus what is 10? Well, that's going to be 4. I've got a 2 and I've got a 4 meter. Give me x. So let's do some Pythagoras. X squared is 2 squared plus 4 squared. That's a Pythagoras add because I don't know the longest side. So x squared is equal to 20. So x is equal to root 20. And I'm just going to leave it like that right now. This is in paper 2. You do that on your calculator. You're going to get 4 point something. I'll just leave that. Well, as you know, I'll do it just now. Yeah, so 4.47 then. So my total length is the 6 from up here and the 4.47. That's going to give me 10.47 meters total length. How many sections am I going to need then? Well, if they come in 2 meter sections, I almost get 5, but I'm going to need 6 sections then, aren't I? 6 sections. Because 5 times 2 is 10, which is not enough, so I need to get 1 more section. And to work out the total price, well, if 1 section is equal to 21.40, 6 sections, I'm going to be timesing that number by 6. As you get from 1 to 6, you times by 6. Times that by 6. I'll just pause that while I do it. That's £128.40. Oof. It's always a relief when I get, it's very easy to make a little sick. But yeah, fine. So fantastic, got that one. And the next one, I'm running out of time, so we'll try and do this quickly. The area of the grass. So have a little think about that. The area of the grass. So the way I see it is you've got 3 sections. You've got the inclined section, then these 2 rectangles. So let's think of our dimensions. So yeah, we'll do 2 times 10, do 2 times 6 and a half of 2 times 4 because we've got 2 rectangles and a triangle, or 36 meters squared. Sorry, I had to rush that last bit. Hope that was helpful, and I'll carry on this series on the next video. Thank you very much.